So let's jump into exactly what we have done so far. So this is a quick snapshot of all the integrations we have done so far, right? In terms of topology, wired, wireless, flow visibility of all the flows from the devices, again, whether they're coming over wired or Wi-Fi. Compliance, we'll talk a little bit more about it. It's a very popular feature with a lot of our customers to realize what kind of upgrade they need to do for the given version of software they are running. There's a device analyzer view. Again, this feeds into across wired Wi-Fi to be able to get a full unified view of everything that you have in your system. A single sign-on model where once you sign on, you can seamlessly move between the Wi-Fi and wired provisioning. And finally, this IoT vision, which we introduced in the last about quarter or so, we'll have a talk a little bit more about it. The idea here is to bring in a unified way a lot of the quality of experience, location, and some IoT-specific characteristics into the single, easily consumable dashboard. So this slide essentially captures where we are going, right? The thought process here is, on one side, the left side of the brain, so to speak, we have state streaming. The state, data, control plane, and management plane states are streamed. And when we're talking about streaming here, we're talking about per packet streaming. We're not talking about sample flows. So those come into this NetDB. And once it comes into NetDB, we have a consumable way, so software way to actually consume this data. And that's when the virtual assistant kicks in, which is then able to consume this data, generate situational analysis, and then basically able to remediate by talking back to this Cloudvision and saying if this device is compromised, if so, what remediatory actions you need to take, such as putting it in a quarantine VLAN, shutting down the port, and so on. So this slide, essentially, we want to capture the importance of keeping our architecture open. While we have focused a lot on keeping our Cloudvision-based data modeling enhanced, we also want to make sure that the openness of the architecture, the inherent openness, whether you're tapping into our streams or whether you're consuming the data through the Cloudvision, that interface is available for people to customize and build their own mechanism on top of what we are offering. And in this context, you'll hear a little bit more. There's this whole open config-based model that we have implemented that you'll hear in more detail down the line. The proactive, predictive, prescriptive model, this is sort of essentially the fundamental way in which we have architected all our products. In the proactive model, basically make sure that the product meets the basic requirements, everything that we have learned, telemetry, and all the infrastructure capability. In the predictive model, it's sort of more to do with operations. Obviously, you can build what you want, but the operating conditions could be different. How you adapt to that operating conditions, what kind of knobs you provide. And finally, the prescriptive model, what kind of feedback you get. It's sort of like the way of driving the car. When you're driving, you want to get some real-time feedback to be able to make some adjustments to road conditions and so on. Bottom line is, what's the business outcome? And those are the quantifiable business outcomes that we have seen in this model.
Sir, what do you mean by simplified designs? I know that some topologies are a little more complex than they have to be, but I believe firmly there is an irreducible complexity to some designs. How do you propose that you're reducing that?
So it's not so much the deployment design complexity alone that I'm talking about. It's how we build the product. So for instance, if you look at a more traditional campus network, you have all this three-layer, right? Access, aggregation, core. And one of the things that Arista has been extremely successful in data center, which we're bringing to the campus, is the ability to go to a simple leaf-spine model. The leaf-spine model comes with inherent capability for redundant network path. So a failure of a single link or failure of a single switch is not as catastrophic. Not that we're happy that switch failed, but then the impact on the business, impact of the network operations is far reduced. That's really the part that we are trying to capture in a simple, consistent design. Okay, coming back to this IoT vision, the thought process here is to provide a contextual view of the wired wireless dashboard in terms of how the endpoints are progressing, various forms of traffic analysis, combined with a focus on IoT, right? So what is special about IoT? Obviously, there's no people. Its behavior is sort of fixed. So there are some interesting dynamics we can show in terms of how this device is functioning in the network.
Kumar, quick
Leverage
question.
dashboard. This is something we've been extremely successful with a lot of our customers. The idea here is to be able to tell customers that for the version of software they are running, where you can filter either by wired or wireless, you're actually able to figure out whether you want to do the upgrade now. Is there some vulnerability? Are there other issues? And the details down below goes down to either the fixes that we put in or there are vulnerabilities that are open to this system.
Thanks, Kumar. Just so as we embark on the discussion, I understand, you're implying that everything is Arista full stack, or at least certainly LAN underneath the wireless network, and everything you're talking about. But what happens if we are, not Arista on the LAN side? Yeah, I'm just curious, is what you're presenting still valid on the wireless side, or is what we're going to see on the wireless side absolutely dependent on Arista switching also being involved?
Yeah. So the answer is in two parts. First of all, we have not hard-coded anything to make sure that this works only when it is all Arista wireless, all Arista PoE. That's not the case at all. In fact, we have several deployments where we find only Arista PoE with Aruba or Cisco APs, and vice versa, Arista APs going with other vendor switches. The architecture itself is not tied to the fact that these two need to be together. These are individual pieces. They're modularized, right? So basically, if you look at it from Cloudvision perspective, the telemetry that we are streaming, if we get to stream or see only from the AP, it'll just work with that, right? There's really no issue with that. It's not like those functionalities go away. It'll be enhanced if we get more telemetry from the switching side, but it doesn't have to be. And finally, I just want to talk about the data plane integration, right? Mojo was one of the companies which truly believed in the controllerless architecture, and that vision continues to take root in Arista. What I mean by that is we are still controllerless, but importantly, a lot of times people want to be able to tunnel the traffic. And when you want to tunnel the traffic to different points in the network, you don't need specialized hardware. It actually works off of our switch. We just use industry standard VXLAN. We still support EOGRE, but internally for all our corporate enterprise use cases, all this encapsulation happens over VXLAN. The advantage is we can take advantage of the rich VXLAN ecosystem, number one. Number two, all the switches in between are able to see the packets and generate telemetry. It's not completely couched in some proprietary protocol. And there is no additional sparing in terms of additional hardware. It's basically our own PoE switches or other Arista switches that are able to terminate these VXLAN tunnels. The second part, or the second point that I want to call out here is this integration with the in-band network telemetry model, where we are able to generate postmark packets all the way from our access point. And it is not hardware dependent again. What I mean by that is if there are other switches, whether it's Arista or third-party switches, which are not capable of INT, we are still able to control and generate enough telemetry. And this actually gives a runtime telemetry with nanosecond timestamps. So you're actually getting not only the telemetry and data counters and all the other information, you're actually getting a full runtime information of how the packet went through the network, what kind of congestion it experienced when it came to what interface of a switch when it went out, and additional details in terms of the runtime capability of the network. So those are sort of the key elements of the wired wireless integration that we have done. At this point, Tom, I'm going to hand over to Andre to take us through, a realization of a lot of what I called out here. Thank you.
All right. Thanks. And thanks, Kumar. So I'm Andre Pesh again. I run the Cloudvision software engineering team here at Arista. And so really excited to be here. As Kumar said, I want to help kind of take you through the product and talk about, make real some of the things that Kumar was talking about. But more than that, I hope to leave you with kind of, and really highlight the power of the platform we built here with NetDB as this central data lake of all of this data across the network, as well as AVEN or analytics capabilities. Because we have this unprecedented access to data. And by that, I don't mean access to, wireless edge data. It's not just about the access switch, the AP, the wireless endpoints connected to it. We've built a platform that gets the data across the entire campus network, wired and wireless, through the data center, into your private cloud deployments, right? The entire enterprise network. And this focus on building a platform for that whole use case, I want to highlight in some of these demos the power that brings to the operator who needs to then manage this wired and wireless deployment. right? And especially when you compare this to some of the more point products out there that are only focused on certain parts of the network, or where there's kind of overlap between different competing products, I think this unified platform is really going to serve us well and be a big differentiator for us going forward. So that's what I hope to really highlight here. I hope that at this point, I know it's Mobility Field Day. We've talked a lot about wired networking. We're going to continue to focus. I'm going to focus on this network operator that's managing the whole wired and wireless, experience and deployment. And then don't worry, yes, we're going to have people come in and really focus on our cognitive Wi-Fi capabilities. But I'm going to start with kind of the day one monitoring operations, use that as a way to kind of introduce the platform, and then go into what I really want to talk about, which is kind of one of the core workflows, is how do I detect, troubleshoot, remediate issues in day two user troubleshooting. And so if there aren't any other questions before then, I'm going to switch the video here. All right. So, and I should say, please interrupt. I know I've got one video. I'll try to pause between sections, but go ahead and yell. I'll deal with it. Don't worry. So here we are with Cloudvision. It starts with full access to the entire campus network, right? Access switches, APs, but also your spine layer, and of course into the data center. One of my favorite views is the topology view. So this gives you that entire view of the enterprise network. And of course, it doesn't just stop at the kind of campus edge. You can go into the data center and private cloud. We also, I think this was asked earlier, we ingest data from third-party devices. So here we have a third-party device, and we know that we're going to be in deployments where there are third-party devices. But importantly, one of the things we've done here is we've really standardized our internal models and the way that we ingest data from third-party devices on OpenConfig and GNMI for Wi-Fi and for wire switches. And this is also the API and the data model that we expose northbound to our customers for getting data from the system. And so Murthy is going to talk about this a lot more later on in the context of Wi-Fi. But this is a great capability for our customers because it means that they can actually build vendor-agnostic, multi-vendor tools both to their management plane, but also to the devices themselves when that makes sense, right? And so this architecturally, I think, is a really big advantage for our customers here. But it also makes it really easy for us to integrate in third-party devices. One of the key kind of architectural advantages of Cloudvision is the end-to-end state streaming infrastructure. So there's no pulling this system anywhere. We get every state change from every device over time. We store it in this cloud-hosted time series database, and that then can be visualized within the network. So here we're looking at the kind of counters updating in real time, and again we stream the entire state of the network, right? So we have this unprecedented access to data and very granular data, and this is really what's required for network assurance. And so that network assurance we can then visualize on the topology view as this great canvas, right? So this can be things like, what are my interface speeds or my error rates? Here we can drill down into uplinks that are having errors, right? But it also comes with more generalized network health detected by our backend analytics. So we'll talk about this a little bit more, but we can look here, we can see all of this state both for individual devices, but also aggregated at these containers. So you can look at kind of building health and then drill down to where it is. And then importantly, we're not just doing management and control plane information. We collect flows from the entire network with SFlow, IPFix, and INT. And this allows us to then know not just who's in the network, but what they're doing. And we can visualize that on top of, in this case, the topology view as I pause here. And I want to highlight one thing that Kumar was talking about, which is INT. This is something you may not have heard of. It's called in-band network telemetry. But it's a great example of some of the capabilities in modern ASICs today. If you know about SFlow, it's for statistical sampling of flows. You get a sense of what's going on in the network. IPFix, which our access switches support, gives you full flow tables. But INT allows you to really pinpoint a user or an application within your network and deterministically see that the packets of those flows go through the entire network, right? So you can go from a wires client to the AP to your access switch, through the campus, to the data center, to the application that's being accessed. And so this end-to-end visibility as a troubleshooting tool is really, really fantastic. I think there's a lot of promise for this for the broader enterprise, but especially in the campus. And we'll highlight a little bit of that later as we get into more of our day two operations.
So before you move ahead, is this running in the cloud somewhere, or is this running on premises on a server? And is that like some $500,000 box that's crunching a bunch of data all day long? Like this appears to be performing quite well, and so I'm sort of wondering.
Yeah, no, that's a great question. So we have a cloud first architecture, so it's a Kubernetes cluster running these applications. We run it as an Arista hosted managed cloud service, but we also have customers who run it on 3-node clusters on premise, and that decision is often dictated by the specifics of the customers. We support both. From an engineering perspective, it's the same application, right? So we're not building two different products. You have the same capabilities there. I believe this particular video was within our campus POC setup on-prem, but we actually have the exact same thing in a cloud setup. So, but no, it's not, it's standard servers, if that makes sense.
And so some of your competitors are calling their management overlay standard servers as well, that are these boxes that are fully loaded to the hilt. Any idea what the compute requirements are if someone wanted to host this on premises?
Yeah, sure. So obviously in the cloud, you get this multi-tenant infrastructure. A lot of customers on a infinite pool of shared resources. On-prem, you have a single tenant. I believe it's 64 gigs of RAM per node, and it's a dual socket. I forget how many cores they're hyper-threaded, right? I mean, this is not the high end of the server market. This is really where's the nice price point of the server market. And the nice thing about our architecture is at the point that resources are an issue, what we want to support is going from 3 to 5, right? So you're not buying more and more and bigger and expensive boxes. You actually leverage the fact that you've built this, cloud scale architecture and leverage that on-prem.
So add more boxes.
Yeah, I mean, bigger and bigger only works to a point, unless you're paying $1 million.
Okay, awesome, thank you.
So
yeah, thanks for the question.
You could build this out in a secure facility without having to touch the cloud, theoretically.
Yeah, we have as Arista, we have a broad spectrum of customers. We have a large number of Fortune 500 financials who are not running their infrastructure in the cloud service. So when they're leveraging Cloudvision, it's always on-prem. In the campus context, a lot of the customers there, especially driven by Wi-Fi having really driven this within the market, there's a much broader acceptance for cloud deployment. And so especially for a customer coming who has mostly a campus-focused deployment, or they're starting there, we see those customers go for the cloud service a lot more. But again, all depends on the customer profile. But absolutely, if you have a restriction on not being able to run your management infrastructure analytics or expose that data to the cloud, not a problem.
How many, let's call them endpoint nodes, can this support as well? Like at the very bottom of your org diagram here, is there an upper number?
I'm sorry, endpoint nodes, you're asking for kind of scale limits?
Yes, sir.
Yeah, I mean, excuse me. It's always a little bit complicated because we have a bunch of different deployments. We have high-end, large router deployments, data center deployments. Our general rule of thumb on the access switch side, I believe, is up to about 1,000. On the switch side is about 1,000, but on the AP side is in the. I'm looking at Kumar.
Per device, per AP, for 20 devices, so it scales.
Yeah, it's like 20,000 devices or something like that. So it scales pretty well for an enterprise deployment. I can get back to you on the specifics there.
Thank you.
Is there a cost difference then between using your cloud-based system compared to having your own on-prem system?
Yeah, I mean, I think there's two different costs to be aware of here. One is obviously the box cost, right? So in the cloud, we're taking the cost of the physical infrastructure. There's a much more important cost there, or the cost there, which is the operational cost, right? I think having a management system, any management system on-prem means that you have to manage the maintenance of it, right? You have to do upgrades, schedule downtime, all that. We have an SRE team that manages all of that in the cloud service. And so, I'm not the expert on our price point, so I'll defer the question on that one. But there is kind of an operational and infrastructure cost that we're taking on in the context of the cloud service. All right, I'm going to keep going here if that's okay, just to make sure we don't run out of time, although I don't see a timer, which is always dangerous. Let's see. So I've talked a lot about infrastructure things. Let's now like move it back to the user, right? Ultimately, in the campus context, it's all got to come back to the user, to the devices in there. And so in Cloudvision, as Kumar mentioned, we have features like Device Analyzer. This is fingerprinting all of the devices, wired and wireless, in the network, identifying who they are and where they are, right? And so we build this context of like, what types of devices are in your network? And then using the data we have about all the device in the network, like, where is it? What is it doing? And using our flow data, like, who is it talking to? What applications is it using? Things like that, right? So you have all this context around data, around endpoints that can be leveraged in our analytics and all the other workflows, which ultimately are kind of where the network operator's job like starts and ends, is with that user, right? And then finally, kind of rounding out our day one visibility, our dashboards, right? So these are built-in and customizable dashboards. Here we have one looking at, Campus Edge with IoT Vision. Who are the users? Who are the top talkers? What are the devices? What are the events that our backend analytics has surfaced that impact these, right? But also all the access ports, right? PoE, .1x information, all the things you might want to know about that kind of edge of the network. But of course, we also have information about the full campus fabric, right? Like, what is my campus fabric health, or fabric to data, campus to data center connectivity, et cetera. We can all build these in these dashboards, which give you point in time, but also historical access to that full data. And one thing that's great in the context of the cloud service is that our TAC team has access to the exact same data, right? So you have this very different experience of, let me pause here. You have this fundamentally different experience with TAC in customer cases because we have this access to this broad amount of data in the system.
So Andre, with what you're showing us, are we looking at something everybody gets, or is this a, by choice, different licenses, build what you need, pick what you need, pay as you go, or what's the model that we're looking at in that context?
Yeah, so I'm going to let someone else jump in and correct me, but I don't think that we don't have any kind of price tiers or feature tiers at this point. So you buy Cloudvision. There's one feature tier for Cloudvision for a set of customers who really only want kind of the config management capabilities. It's not very widely used, but broadly you buy Cloudvision, you get the entire experience. And it's a kind of a per device license model. So it doesn't really matter what you're doing on the device from a Cloudvision perspective. This may change in the future, but we've done this since the inception in launch of Cloudvision in 2015.
Thank you.
Yeah. Any other questions? I'm gonna go into kind of day two operations next, and kind of tie this back into what is fundamentally kind of the main mission, right? Who are my users? How are they doing? Are they getting on the network? Are they having issues, right? And so I'm going to start with kind of the traditional reactive model, right? So you're a network operator, you get a trouble ticket, someone calls you, you have an issue, right? How do you debug it? And so with Cloudvision, if you think historically, your problem is like, are you wired or wireless? Who are you? Where are you? Like, do you know what your MAC address is or IP address? Like, what's my IP address, right? So how do we bring all this together with Cloudvision? So with Cloudvision, we have an easy, search. You can just search for the username, hostname, MAC address, IP address. These are all things that we have picked up, through our various fingerprinting. You get everything we know about the device. Where is it? Where is it in the network? And then importantly, what's it doing, right? And this for wired and wireless endpoints. But obviously this isn't the goal, right? The goal is not to play this reactive game, right? And so what we want is for Ava, looking at this streaming telemetry data, to be able to surface issues that tell you that there's a problem before your users actually call us. And so here's this example from the infrastructure side. So we have a bunch of of anomaly detection, kind of backend analytics that are focused on certain. Sorry, I'm a little ahead here. I'll let you. We look at a bunch of different metrics with our anomaly detection system. This is based on QSUM sequential analysis, where we basically are building this model of what's normal and what deviates from that. And so here in this example, we're looking at the latency measured across the network, across your campus network, right? And so you have your typical latency, and then it spikes, and it could be sustained, it could be temporary, but that spike due to congestion or a network change, this is telling you that your applications and users are going to experience that network differently now. So you can go say, okay, well, is this suspected? What happened? What got changed? This is a very infrastructure-focused example, but this is one way to be notified, okay, something's wrong in the network. But then, of course, we kind of want to take it from the other side, too, is like, what is my user experiencing? So if we go into our kind of Wi-Fi dashboard here, there's this great feature called Application Quality of Experience. And Karan is going to go into a lot more detail here on the specifics of the model. But basically what we're doing is we're tracking users and their use of applications within the network. Right, so you can see a set of applications here, and we have a model that can predict, what was their quality of experience at that time, right? And then we have a root cause analysis engine that can look at all of users and all of their applications experience to determine why are certain users having a bad quality of experience. And so we can put all this together. Here we had our system test team go and create a problem in the network. We see a set of users who are having a poor application experience, right? We click into the device, and we can see the root cause analysis. It looks at the holistic set of data we have and say, look, this is not an issue on the wireless side. This is a wired issue, right? We're seeing issues on the network traffic. And so that brings us back to looking at that full end-to-end workflow, right? So we can look up the device, look up the flows, we look up a representative flow on the network, and then go to try to view that on the topology. And in this case, we have INT configured everywhere. So not only do we have the flow, right? We're not just told, hey, here's the path, now go figure out what's wrong, but we get hop by hop latency via INT, and we immediately see, that our sys-test team has basically created 4 seconds of buffering here by just hammering the network. And we immediately say, okay, we got this access point to access switch to our spine switch. This is where the issue is. What do we need to do to go and prioritize the traffic, et cetera. And so hopefully this gives you a sense of kind of the holistic kind of capabilities of the platform, but importantly, how we can leverage some of these, differentiators and key features in modern networks on the wired side to really enhance kind of the end-to-end wired and wireless debugging experience. And with that, I don't know if we have more questions or if we have time. I'm gonna quick time check here, but love.
Yeah, is there a way of splitting that kind of application oversight across different sets of users or different groups of users rather than the whole network?
Sorry, is the question from an application quality experience perspective, are you looking at holistically, or what happens if you have multiple campus deployments that are kind of fundamentally independent?
Yeah, I guess both. I'm thinking if I've got a particular group of people that I know are working on a specific application, is there a way to target that only for that specific group rather than, say, the whole network?
I don't know the answer in terms of if what you're hoping for is to just not track the application. We just do this in line, right? And so I think, but our root cause analysis absolutely looks at the differences based on location, right? Because we know the location of different devices. So if you have application issues within one campus, that's not confused by that same application being used in another campus, if that makes sense. And we have support for kind of custom applications too, right? Because you may have some enterprise system that you're using internally that that you want to track as well, not just your video calls or things like that.